So let's go through an example using z-scores to determine percentiles. Cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. What is the percentile for a 20-year-old man with a cholesterol level of 190? So we don't care about how old this guy is. We care about his cholesterol level. It's 190. So remember, my z-score is my data value minus our mean over our standard deviation. So I'm going to take 190 minus 178 over 41, which gives me 12 over 41, which is 0.29. So that's my z-score. I need to use this to find my z-table value. And in order to do that, I need to go to a z-table. So let's do that. Here I've got my z-table. I got a z-table value of 0.29. So this right here is my z-table value. That tells me the percentage of values less than my z. So I have a z-table value of 0.6141. So the percentile for this man, we would want to round this. So this would be the 61st percentile. That's our answer. Changing colors again. What cholesterol level corresponds to the 90th percentile? The level at which treatment is necessary. So remember, our z-score is our data value minus our mean over our standard deviation. I don't know what our data value is. I have our mean, I have our standard deviation, and I need to figure out what z-table value corresponds to the 90th percentile. So I'm going to do that by going to the z-table. So we're going to find the value on this side, right, because it's above the mean, that's closest to 0.90. So let's zoom in. I've got 0.9032. Here I've got 0.9015. Oh, this is closer, 0.8997. So what's the z-score associated with this? It's going to be 1.2.8. So now I have a z-score of 1.28 equals my data value minus our mean over our standard deviation. And now I just solve for x. I'm going to multiply both sides by 41. That gives me, I didn't do that. I just have the answer written down. 41 times 1.28. Okay, that gives me 52.48 equals x minus 178. Now I need to add 178 to both sides. That gives me an x value of 230.48. Let's go ahead and round that. So x equals 230. So a cholesterol level of 230 would mark the 90th percentile. Okay, let's go through a couple more examples. So what's the percentage of men in this age range that have a cholesterol level of 188 or lower? Okay, so I'm going to take my z-score because it gives me the values lower, right? So if I have a normal distribution, I've got my mean in the middle, got 188 up here. This is asking me how many people have a cholesterol level, what's the percentage with a cholesterol level less than 188. So I can look this up. I have 188 minus 178 over 41. That's 10 over 41, which is 0.24. So now I go to my z-table. Let's go to a clear one. There we go. I go to my z-table. I go to 0.2. I go to 0.04, and I find a z-score of 0.5948. That's the area over here, 0.5948. So we can go ahead and round this. What percentage of men? Let's just go ahead and say 59%. Now, what is the percentage of men? My second question is, what is the percentage of men in this age range that have a cholesterol level of 188 or higher? So it's asking me over here. What is the percentage over here? How can I figure that out? Well, the area under a normal curve is 1. So I can take 1 minus 0.5948. That gives me about 0.61, right? So we would have, sorry guys, I was looking at the wrong note. So 1 minus 0.5948 is, let me just go ahead and do that. 0.4052. So let's go ahead and round this. So about 41. Yes, oh my gosh. So 41% of men in this age range have a cholesterol level of 188 or higher. So the area over here was 0.4052. Remember, the entire area under a normal curve is 1. Last but not least, I want to know what's the percentage of men in this age range that have a cholesterol level between 188 and 192. So let's sketch this out so we have an idea of what's going on. So I have my normal curve, my mean of 174, and I want to know what percentage have a cholesterol level between 188 and 192. So I'm trying to find the area right here. Now we already know from our previous example that men with the area over here, because we have a cholesterol of 188, in our previous example we found the area over here was 0.5948. So I'm going to go ahead and write that down. This is 0.5948. But I just want to know the area in here. So what I'm going to do is I'm going to find the area for this entire part, which would be the Z table value for 198, and then I'm going to subtract from that 188 in order to get our final answer. So let's find the Z table value for 198. So Z equals, let's do this in green, shall we? Z equals my value minus my mean over standard deviation. So I've got 192 minus 174 over 41. That gives me 0.34. Now I need to find the Z table value. So I take this 0.34, that's my Z score, to the Z table. So I see 0.3, I go to 0.34, and I see it has a Z score, a Z table value of 0.6331. So the area in this entire thing is 0.6331. And the area in blue over here is 0.5948. So if I take my entire area minus this blue, I'm just left with what's in between these two. So 0.6331 minus 0.5948 gives me 0.0383, so about 4% of men have a cholesterol level between 188 and 192.